Okay, two equal chords. I have two equal chords AB and CD of a circle. I have two equal chords AB and CD of a circle with center O. Intersect each other at point P inside the circle. There are two equal chords who are intersecting each other at point P, and these chords are inside the circle whose center is O. I have to prove that AP is equal to CP. AP is equal to CP and BP is equal to DP. So clearly, first of all, I will do a construction. That is, I am going to draw OR perpendicular on CD and OQ perpendicular on AB. I have to draw perpendicular there and perpendicular there. And after that, I am going to join this. So this is the diagram. First of all, I have given two equal chords. Two equal chords means AB is equal to CD. And if these are two equal chords, then the perpendicular which I drawn OR on CD and OQ on AB, these two are also equal because equal chords have equal distance from the center of the chord. If the two chords are equal, then their respective distance from the center is also equal. Consider this is the chord, this is the chord, both these chords are equal. Then their perpendicular distance from the center, this is the perpendicular distance from the center, these are also equal. Remember that. Okay, so clearly I have first OP square, clearly OP square is that OR square plus of PR square. What I did, I applied PGT in triangle OPR. OPR, hypotenuse this, perpendicular and base. Okay, so what I have written, OP square is equal to OR square plus of PR square. Okay, so OP square is equal to OR square plus of PR square in triangle ORQ. Okay, this is in O, it's a OPR, so it is in ORQ. Okay, now I'm going to move in that triangle where I also applied Pythagoras theorem. Clearly OP square is the hypotenuse, OQ square plus of PQ square in triangle OPQ. Okay, if these two sides are equal, then these are also equal. Okay, so I have OR square plus of RP square is equal to OQ square plus of QP square. Now OR is equal to OQ, OR is equal to OQ. And if I write OR square plus of RP square is equal to, instead of OQ, I can write OR because both these are equal. So instead of OQ, I am going to write OR square plus of PQ square. I am going to cancel these terms with these. So what I left, that is QP square is equal to RP square. I can cancel out the square, so I have QP is equal to RP. Clear? Now I have AB is equal to CD, which is given that the two chords are equal. Now dividing both these part by 2, AB over 2, CD over 2. So AB over 2 is QB. AB over 2 is QB. Similarly, CD over 2 is DR. CD over 2 is DR. Okay, so adding 4 and 5, this is my equation 4th and 5th. I'm going to add both these terms. So QP plus of QB is equal to RP plus of DR, and this one becomes PB is equal to PD. PB is equal to PD. So PB is equal to PD, it's hence proved. And I have also to prove the second. Let's move on to the next. Now if I'm going to subtract AB minus BP. AB minus BP. Then I have PB. AB minus BP. AB minus BP. What I have? AP. And from CD, I have CD. This is CD. And I'm going to subtract DP. That is DP from this. CD, I'm going to subtract PD from CD. I have left with CP. So this was the next equation, that is AP is equal to CP. Don't get confused. Just first draw OR perpendicular on this chord and OP perpendicular on this chord. Okay, OQ perpendicular on this chord. Okay, then join this one. Clearly, if number one, if the two chords are equal, then the perpendicular distance from the center is also equal. So these are equal. Now apply PGT in that triangle and PGT in that triangle. After that, you will know that both these terms are equal, then these two terms are also equal. Then substitute one's value in that equation. Okay, after cancelling out, you will get this result. Then again write AB is equal to CD, which is the given part of the question. AB is equal to CD, and we are going to divide both of these two chords by 2. After dividing AB by 2, I have QB. After dividing CD by 2, I have DR. Okay, so perpendicular from the center bisect the chord. On adding 4 and 5. After that, I have equation 4 and this equation 5. Adding these two, I have PB is equal to PD, which is the second part, and subtracting AB from BP. Subtracting AB from BP means in this equation I subtracted 1 and 6. Then I get the next result. Okay, so it's quite easy. You can do it yourself. Let's move on to the next, which is question number 12. This one. In the following figure, OABC is a square. OABC is a square. OABC is a square. A circle with center O is drawn, which meets OC, at point P and OA at point Q. I have a circle whose point is O and it meets OC at point P and OA at point Q. I have to prove triangle OPA. Triangle OPA, this one, OPA is congruent to triangle OQC, this one, and BPC. So this triangle is congruent to triangle BQA, this one. Clear? So let's move in triangle OPA and triangle OQC. OPA and triangle OQC. Clearly, first of all, this angle is common in both of these triangles. In triangle OPA and triangle OQC, this is common. So I can write POA and QOC common, and angle in a square is 90 degree. Both, I can say that this angle is 90 degree for both the triangles, or it is common. Now OP is equal to OQ. OP is this is my first, which is common for both the triangles, and OP is equal to OQ. OP is equal to OQ. Radii of the circle are equal. Radii of the circle are equal. POA A. Oh, I have already done. It's 90 degree common. OP and OQ are the radii of circle. Now AO. AO is equal to OC. First of all, this angle is common. OP is equal to OQ because these are the radius of circle, radii of circle. So the radii of circle are equal. Now OC and OA. It is a side of square, and I know that all the four sides of a square are equal. That's why AO is equal to OC. Sides of square are equal. So by side angle side rule, triangle OPA is congruent to triangle OQC. Second, I have to move on triangle BPC and BQA. BPC and triangle BQA. So I have clearly BC is equal to BA. BC is equal to BA because these are the side of square and they are equal. Next, angle BCP. BCP is equal to angle BAQ. I know that all the angles of a square are 90 degree. So this one is 90 degree and this one is 90 degree. First of all, these two sides are equal because these are the sides of square, and these two angles are equal because all the angles of a square are 90 degree. Okay, now can I write CP as OC minus OP? I have the bigger line OC and there is a point P. So can I write CP, this one, as OC minus OP? I have a line, this is OPC. If I have to write CP, then what I will do, OC minus OP. Now OC minus OP is equal to OA minus OQ. OA minus OQ. OA minus OQ. OA minus OQ. Okay, since OC is equal to OA, OP is equal to OQ. OC is equal to OA because these are the sides of square, and OQ is equal to OP because these are the radius of circle. The bigger one are the sides of square which are equal, and these are the radii of circle, these are also equal. So by doing this, I have CP is equal to AQ. CP is equal to AQ. So I have by side angle side rule, these two triangles are also congruent. These two triangles are also congruent.